Okay, ladies and gentlemen, we have Pythagorean Theorem and its converse. Now, Pythagorean Theorem you did in Algebra 1. We're not going to spend a ton of time on it. Of course, Pythagorean Theorem is a squared plus b squared equals c squared. Now, technically, I just lied to you because the reality is a, b, and c have no meaning. What it really is leg squared plus leg squared equals hypotenuse squared. Okay, so leg squared plus leg squared equals hypotenuse squared. You know what would be cool is if my camera was not frozen. So let's go ahead and pull that camera up again. Hey, magically it appears. Okay, so we have a squared plus b squared equals c squared. I have 15 is one leg, so I square it. Plus 35 is another leg, so I square it, equals hypotenuse squared. So let's take it. 15 squared is 225 plus 35 squared, 35 times 35, or you could use the square button, and it's 1225 equals hypotenuse squared. That gives me 1500 equals hypotenuse squared, and so I square root both sides, and I have to do this. Well, that's going to give me 2 and 750, 2 and 375. 5 and so 375 divided by 5 is 75. 5 and 15, 5 and 3. So there it is. I have a pair of 2s, a pair of 5s. So I get 2 times 5 times the stuff that's left over has to stay under the square root, and that's going to be 15. So it's 10 root 15. 10 root 15. Now, just for giggles, if I take 10 times the square root of 15, I get 39-ish, basically. 38.7, which makes sense for the hypotenuse. That's standard Pythagorean theorem. All right. The other thing that we can do is the Pythagorean theorem converse. Pythagorean theorem converse says this. It says, given a triangle with 3 sides, 3, 4, and 5, provided it has a right angle, because the Pythagorean theorem and its converse only work if you have a right angle. The question is it really a right angle? I don't know. Let's find out. 3 squared plus 4 squared, does it equal, question mark, 5 squared? So I get 9 plus 16 equals 25. 25 equals 25. Yes, yes, indeed. Those two are equal, so this is definitively 90 degrees. So in this case, we know we have a 90. We can find a missing side. Here, we have 3 sides. Is it right? I don't know. Does it fit the Pythagorean theorem? If it does, it's right. If it doesn't, it's not right. Let's do another example. The other example is if I have this one. If I have 4, 7, and 11. Does that, well, actually, that won't even make a triangle. 4, 7, and 10. So let's see. 4 squared plus 7 squared. You'll remember, the hypotenuse is always going to be the biggest side in a right triangle, so it's the one that goes off by itself. So I got 16 plus 49. Does that equal 100? The answer is no, not even close. That's 65. 65 does not equal 100, so it is not a right triangle. Now, by the way, if the hypotenuse squared is greater than the legs squared plus legs squared, then the triangle is obtuse. If the hypotenuse squared equals the legs squared plus legs squared, it is right. If the hypotenuse squared is less than the legs squared plus legs squared, then it is acute. So equal makes 90. Hypotenuse squared is bigger is obtuse, and less than would be acute. So not only do we have the Pythagorean theorem, we also have the converse. We also have a couple other things that we can begin to learn about triangles. By the way, a couple things you might want to memorize. 3, 4, 5 is a Pythagorean triple. Okay, another one is a 5, 12, 13. These combinations happen over and over and over again, as do 1, 1, square root of 2, as does 1, root 3, and 2. All of these are special, and they're called Pythagorean triples. So, Pythagorean triples. With that, you should have enough information to do your homework.